you will see a holistic view of the overall architecture and design. So the first component of a platform like this is, we call it tool interface. And this tool interface is basically an abstraction layer between the solution and the various tools. So as you can see, there are tools at the top layer, and then these are solution components. And then in the middle lies this interface, which integrates the tool and the solution components. This tool interface can be designed by technologies like web services or RMI or COM, because you need to pass on commands from your solution component to the tools. So you can use technologies like web service calls, RMI or COM. Now, as you can see this diagram, I have mentioned few components which are core to this solution. And if I can draw an analogy, these components are like minds in human body. So if I have to take a decision, my mind has to take a decision. It takes the decision based on the information stored within my memory. So these components that you see here are basically the information repository for this whole platform. So let's talk each of the component one by one quickly. So the first is GUI control definition. As we all know, each automation tool has its own methodology defined to identify objects uniquely in the application. So a GUI control definition is basically a mapping list of all possible objects and its associated set of standard attributes. So we know that if there is a button object, there are certain sets of properties that needs to be attached with the object. So this control definition will have list of all possible type of objects, and for each object, what are the different kind of attributes that that needs to be captured. So that's definition can be stored either in form of XML or in form of database, but this components has all the definitions, should have all the definitions in place, and you also need to take care of what are different tools that you are integrating, and you should have a comprehensive list of all the controls that are supported by all the tools. So that's the first component. Second is the execution definition. Again, each automation tool differs in their methodology of executing these scripts. So for example, Selenium scripts, Selenium inject JavaScript in the web application for execution purpose, while Water creates a object of the browser. There are some tools which work on the basis of COM. To add to the complexity, each automation tool understands different language. So Selenium understands Java, Ruby, C#, while Water only understands Ruby. If you are integrating any other commercial tool, then they understand different languages, and so on and so forth. So to standardize this wide variety of execution definition, this component is required. What happens is each tool, be it Selenium or Water, has a way of executing, understanding a command and then executing that particular command. So this execution definition engine has to have all the possible execution interfaces for all the tools that you are integrating. So moving to the next component, which is keyword definition, the third one. So each automation tool has list of actions that can be performed, and by actions I mean actions like click, actions like verify, right? So all these actions, there are certain generic actions which are common across different tools, and there could be some specific action with respect to a specialized tool. For example, if you're talking about mobile you are integrating a mobile tool, then pinch to zoom is a specific action that can only be performed with a mobile application or mobile tool. So there are certain generic actions and then there are certain tool specific actions. So all those action definitions have to be part of this keyword definition component. While the implementation of the function can differ across the tools, but there has to be a generic definition available within this component. And finally, as far as the tool interface layer is concerned, the last component is exception handling. So this any platform or solution like this need to have a standardized and scalable exception handling scenario which can work on multiple tools. This can be easily achieved by standardizing the return codes of the keywords that you are going to create for all the actions. With this, I'll move on to next interface, which is authoring interface. Now, this authoring interface basically is based on the fundamental principle that we discussed, is based on end user abstraction principle. And how do we achieve this end user abstraction? Again, by having few components. And as you can see in the diagram, there are three components: common object repository, common keyword repository, and a test data repository. So if you look at common object repository, based on what we had defined or what you have defined in the GUI control definition component in the tool interface layer, the common object repository will capture that information and store it at a common place in form of a object repository file when you are creating your test case. So for any of the tool that you might have integrated in the backend, the repository is common and in a standard format. So that's one of the key to have end user abstraction. The second is common keyword repository. So from the keyword definition file, the keywords will be available as part of a common object repository, common keyword repository, to be used for test case creation. So while you are creating a test case, you should be able to switch between various keywords from various tools without even knowledge of the tool. That can only happen once you have a common keyword repository where all the keywords are available together. You can have segregations just for identification purpose, but they have to be available as part of a common keyword repository. And finally, a common data repository. So common data repository is to store the test data which will be required during the automation execution of a particular test case. The third one, which is one of the most intelligent aspect of this whole platform, is the execution interface. This interface is based on the principle of scalability and adaptability. And this can be achieved by designing this interface and having two separate adapters that you can see in this architecture. So as you can see here, we have a test case adapter and a tool adapter. Now, what does test case adapter do? So this particular adapter parses the test scenario. So once you start your execution, the information is sent to this test case adapter, and this test case adapter parses the test case received and sends each keyword to the respective tool adapter. So for example, if you have created a test case where you have keyword of Selenium, then it will be passed to the Selenium tool adapter. If after Selenium keyword, if you have your SOAPUI key adapter, then it will be sent to the SOAPUI tool adapter. So this test case adapter has the intelligence, and this intelligence comes from the information stored in the execution definition. So by using the execution definition, by using the information stored in execution definition, the test case adapter decides which tool to call, and then the information is passed accordingly. And the tool adapter passes the information or executes the command on the application. The result is passed back to the test case adapter. And then the information, all the information that we have talked about in this design is stored at a common place in form of a DB. You can also use file system, but then file system has its own challenges. So utilizing the concept of DB is much more, gives you much more scalability. So once you have all the information in DB, you can have a reporting interface which allows you to pull a common report together of all the execution that has happened. And since all the information is stored in a common database, one can generate various kind of reports, like comparison reports across various regression executions required for build health check. You can create any kind of report by just writing your own query and then pulling out the data. Having a database gives you a lot more advantages, like it enables multi-user working. So multiple people can work together on this platform while working directly with a tool set like Selenium has its own challenges. Multiple people working together creates redundancy, etc. So those kind of issues also get solved if you have a common database for all the information storage. So let's now look at a real implementation of a solution like this. So we discussed the concepts. What I'm going to showcase now is one of the solutions that we have developed internally, and I'll try to relate to what we discussed so far, all the interfaces that I showcased as part of design and architecture. I'll try to showcase that with an example of a test case that we have created which runs across multiple platforms. Post that, we'll also discuss some of the existing open source solutions which can be utilized for building such kind of solution. But let's start with what we have developed internally. So let me open the solution which we call SOAPUI. So as you can see, it's a tool agnostic test automation platform. So I'm logging into this platform to access my project. Let me open a project which has already been created in this platform. So this is the main interface that you see, and if you try to relate it with the design and the architecture that we discussed, this interface is the authoring interface that we talked about. And as I had mentioned, that authoring interface requires end user abstraction. I'll showcase how that looks like in this particular platform. Now, as you can see, this is a this has a very rich UI, but you can create your own solution in a script-driven format or Excel-driven format. That's your choice. But in the current scenario, it has a very rich UI for making for better usability as far as the end users are concerned. So as you can see in this interface, it has various authoring interface components like test case, which is then object repository, then data repository. All these we discussed as part of our architecture and design. So if I go to test case and expand it here, you can see there are 3 test cases available. One is we have used Picasa application, and Picasa application can be accessed on mobile, web, and through web service. So the same information, so you upload a picture on Picasa through web, you can access it from mobile, you can modify it on mobile, come back and see it on web, and you can also access directly by calling web service which has been exposed by Picasa. So we have taken a scenario where we are accessing a particular image from all three platforms. And as you can see, all three test cases for three different platforms are in one common interface. That's one of the key for the platform or solution to be more adaptable to end users. Now, let me just open and show you how a test case looks like. So I have opened the Picasa web test case, and you can see the detail of the test cases here. And if you look at this test case detail, it's nothing but combination of certain keywords, and keywords are basically the actions that you need to perform on the application. So as you can see, the first keyword is open browser, then there is a common function Picasa web login, then there are keywords like click link, then normal click, then there are certain verification keywords like assert text present. So the test case is basically a combination of various keywords which are available in the repository. Let me show you the common keyword repository that I was talking about. Let me add a new step to this test case. Now I'm trying to add a new step, and here either I can add a step from the function library, but I'll not go into detail of it. I want to showcase the common repository, keyword repository that I talked about. So you see here there are different segregations that we have done just for ease of use purpose. So in the OPKey generic keyword list, we have list of all the keywords. We have put a list of all the keywords that user will require to perform any kind of operation. So whatever step that you need to perform, it's most likely that you'll find a right keyword available in the repository. And if it's not there, it has to be added as part of the execution definition that we, keyword definition that we talked about. So there are various kind of keywords like generic, system, control flow. And there are also some tool-specific keywords that I talked about. So there are tool-specific keywords like for Seculi, Robotium, and there will be more once we add more plugins to this solution. Right now, it is using Selenium, Robotium, and Seculi together. So that's why you see only 3 tabs. And what user just needs to do is to select a keyword from a specific group and then add it as part of the test case. So I can select any of the keyword here. For example, again, I'll select open browser, and it gets added in the list. So that's how you abstract the end user from knowledge of the tool. Here, there is no knowledge required of the end tool that you will be running with. You just need to have knowledge of the action that you need to perform and the corresponding keyword that you need to add. Similarly, if you look at the mobile test case, the process is exactly the same. Since we are using some tool-specific keywords, so you will see some different set of keywords here. But then there are a lot of keywords which are common. Click on button. You'll find it even in the web case. So creation of test case, be it web or mobile, has the same process. You are using the same interface. You have complete abstraction from the tool at the back end. Moving on quickly to the object repository part. As you can see, in the same interface, we have the object repository for mobile and web in a common structure. So user need not know how to fetch repository from Robotium or Appium. The platform itself based on the GUI definition captures the object repository when you are working on the application. Then you have common data repository. So you have Excel-like interface where you can provide the data to be used as part of your execution. I'll not go into much detail of this. Let me show you how do we then integrate it as part of one end-to-end flow. So within a suite, or you can also add it as part of your test case. But here, the 3 test cases that we just saw has been added as part of a suite to create an end-to-end flow. So it starts from web to REST, and it goes to mobile. And that's how you perform your multi-platform executions. Let me show you quickly the execution interface that I was talking about. So once you start your execution, I'm sorry, the agent is down, but I'll quickly explain it. What you need to do is to just select the plugin, and you can select, if this drop down is currently not working because the agent is down, but if the agent was up, you'll see the list of plugins, which means the tools. So as you can see, we have Robotium, Selenium WebDriver, SOAPUI currently installed here. So you can select which generic plugin that you want to run with. It can be Selenium, it can be Sahi, or it can be Water, etc. But the specialized keywords like SOAPUI and all will be decided on runtime. So this way, user just needs to select the generic plugin, and the rest of the decision is taken care at the runtime by the platform itself. Once the execution is complete, as part of the reporting interface, you have one common place to access all the results. So as you can see, this is one of the results from the automation run, and this is the result of the end-to-end flow. So end-to-end flow status is there, and then the individual component status is there. You can expand and see the detail at each step with all the information related to that particular step. You can also see the snapshot of each of the steps that was taken during the execution. So the point is, you have a common place to have reporting coming from all the tools and accessible in a standard structured format, so that user is not looking at individual tool and trying to figure out what happened, whether the test case passed, failed, etc. You have just one common place. You can drill down and figure out what exactly was the result. So we talked about the authoring interface. We talked about the execution interface. The tool interface is basically the internal logic, which you cannot see on the UI, and it also has a backend database that we discussed, from where all the information is being pulled and shown on the UI. So it gives you a sense of how a solution like this can look like. But as I said earlier, designing a UI-based such rich solution might be a long process and will require a lot of investment. So you can also create this kind of solution purely based on script, in form of a script-driven framework or Excel-driven framework. That will be much faster for you to create. So with this, I'll move back to the presentation. And let's look at some of the existing solution. And the question is, can we leverage something which is existing in the open source world? So there are quite a few solutions, but few solutions to be noted are, the first one is STAF, Software Testing Acceptance Framework. Oh, sorry, Software Testing Automation Framework. And you can access it from staff.sourceforge.net. It has a very good capability of reusable components. There are As I said, a lot of keyword repositories are available. It does not integrate currently multiple tools, but it's quite extensible. You can download the code and build your solution on top of it to integrate multiple. So it could be one good starting point for building a solution like this. There is another framework which is Robot framework. It again comes with some very interesting utilities available inside the tool. For example, backend validations. It's extremely good for your backend validation processes like database, file validations, log comparisons, etc. So you can combine staff with robot and start building your solution on top of it. That will be it will increase the overall process of creating a solution like this from scratch.